Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome to Ekeeda. Today we will see problem number 3 on poles and zeros of network functions. So let us see what it is. You can see this problem, it is little bit reverse type of problem. Earlier we used to find poles and zeros and we used to plot them. In this problem, we have been provided with poles and zeros and we have to get network function as well as network parameters. So there is a transformed network which is already given. This is R, this is LS, this is 1 upon CS. That means they are given in their S domain. It is given that it has poles and zeros as below. So poles are at -1 by 2 plus minus j root 3 by 2 and 0 at -1. This is given to us. One more information is given that z of j0, that means instead of this j of s, it is given j of j0 is equal to 1. And we have to determine values of R, L and C. So now what we will do? We will first find out this z of s. Then we will also find z of s by using these poles and zeros. And then we will compare it. So let us start. So z of s is 1 upon cs parallel with r plus ls. So we will solve it. Here I have taken this L common from this S because I want to make coefficient of this as 1. So L is taken common. And here I have just cross multiplied denominator, and this CS and this CS will get cancelled. Now in denominator, in order to make coefficient of this S square as 1, we will take LC common. So write S square first, then RC divided by LC, that will become R by L, and then it is going to be, and this L and L also will get cancelled and we will get a simplified Z of S. So we have got Z of S. Now we will use the data given. We have been given that these are the poles and these are the zeros. So by using those poles and zeros, we will construct one impedance function and we will compare that function with this function. So in the question here, we have been given that these are the poles and this is the zero. So by using this data, we'll write Z of S. This h is some scaling factor which we don't know, we have to evaluate it. 0 is at -1, so it must be s plus 1. And poles are at -1 by 2 plus minus j root 3 by 2. So we can write it as s plus 1 by 2 and 2 terms will be there because there are 2 poles. Now we will cross multiply this numerator and denominator. Now we're going to just multiply them. So this is the Z of S which you have got by using the given data of poles and zeros. And this is the Z of S which we have obtained by using given circuit. One more information is given that Z of J0 is equal to 1. So instead of this S, if we put J0, this becomes 1. That means S is equal to 0. So here wherever you find S, you have to substitute it is equal to 0. So when you put S0 here, it becomes 1. And here 0 plus 1 again becomes 1. So it is equal to H multiplied by 1. And which is given as 1, which is already given J of J0 equal to 1. So that is this capital H, which is scaling factor, is 1. So this is first thing which you obtained. So we can now rectify it. So we have obtained this z of s as s plus 1 upon s square plus s plus 1. And now we will compare this z of s with, so if you compare both, so we'll write it here. And now just by comparing, you can see that this r by l is equal to 1. Also here you can see that this r by l is 1 and this 1 upon LC is equal to 1. Also this C is equal to 1. So L also is equal to 1. So C is 1 farad, L is 1 Henry, and R by L, because L is 1, this indicates that R is also equal to 1 ohm. So we obtained all three. So we'll write them. See, I just compared it. R by L 1, then 1 upon LC as 1, this C as 1. Just substituted the values. So R is 1 ohm, L is 1 Henry, and C is 1 farad. And these are the desired circuit parameters which were required. So thank you very much guys for watching this video. Stay tuned to Ekeeda and please subscribe to Ekeeda. Thank you.